So feel free to share your screen, Linda. Thanks.
Okay. Oops. No. I want to go to the show. Here we go. Can everyone see?
Yeah, all good.
Okay. Terrific. Thank you. Okay. So I am going to talk to you folks a bit about this CUISINES framework for the protocols. As Dennis mentioned, the paper was finally published a few months ago. And for those of you who are veterans of CUISINES, this will be familiar turf, but for the folks who are new to CUISINES, welcome. And I hope you'll find this informative for your planning for the future. So it's kind of difficult to believe that this was now 7 years ago, where really at this Nexus workshop on habitable worlds held in Wyoming, a number of people got together over dinner in a Thai restaurant to talk about ways of comparing the different models that we had on some set of common experiments, which we now know morphed into the Thai intercomparison project, which was hugely successful. As Dennis pointed out, it has its own theme issue, and people are still interested in using this work and expanding on it to go into a second phase. Back in, I think it was 2020 now, we had our first workshop, our predecessor to Buffet, where we talked about the Thai results. And we also talked about thinking of ways to bring a more formalized structure to the way that we did the intercomparisons, hopefully with an eye toward expanding it beyond the GCM world, which was heavily involved in Thai in the first place. And an easy place to look for inspiration was on the earth sciences side, which has been doing these sorts of intercomparisons for years. So the granddaddy of all of this is called the Coupled Model Intercomparison Project, or CMIP for short. So CMIP has been around for over 30 years now, and it has become a pretty formalized process where every 5 to 7 years or so, groups from all around the world come together and perform specific experiments in common with the models that they work on day to day. And the experiment planning involves both benchmarking, so simply understanding how the models perform, and then looking at specific scenarios. Now, the scenarios are not invented out of whole cloth. These are also inspired by community conversations under the auspices of a UN group called the World Climate Research Program, or WCRP. And the WCRP has come up with this concept that they call grand challenges, where periodically there are discussions held among the community to decide, what particular problems are of special interest, perhaps for societal impact, or from the standpoint of trying to improve the models that we already have. So are there places where the models are lacking features that we feel are important to the climate system? And so the grand challenges grow out of the set of concepts that come up in these community conversations. Now, we haven't had up until now really a set of formalized conversations in the community, but we do have similar sorts of documents that decide or direct some of the research questions that we explore as a community for some periods of time. All right, so just a couple of years ago, we had the most recent decadal on origins, worlds, and life. And the emphasis there is on processes that are potentially detectable, which is, of course, of interest to our observation comrades. On the European side, we have the AstroMap, And then dating back to 2015, of course, we have the NASA astrobiology strategy. Now, I will point out that in a couple of years' time, there will be a new decadal. So this will be a decadal for astrobiology research and exploration strategy. And the idea behind NASA DARES, which was just announced as a concept to the community here in the US, is that we will bring together information from the documents of the last 10 years or so, consolidate them, identify where the documents had gaps, and where advances in the science now necessitate thinking about new questions, right? So you can think of NASA DARES as a refresh for a variety of different documents. I will put my Nexus co-lead hat on for a second to say, folks who are members of a Nexus member team will be encouraged to participate in the drafting of this new document, and it is a funded opportunity, so stay tuned. So moving on from all of these concepts and the ideas of framework, and over the course of a number of our previous buffet workshops, and also through the experience of some of the MIPS that defined their protocols early, we eventually landed with a set of principles to help guide how an ExoMIP should be constructed and run. And this was published in July of this year. Thank you to everybody who helped made this come together in the end. This really was a community contribution from everyone. And the key aspect about this paper is that it highlights 5 principles that serve as the foundation, or should serve as the foundation, for any CUISINES ExoMIP that is planned, right? And so what are these principles? Well, first, to define in advance what research question the ExoMIP is intended to address. Right now, we have an embarrassment of riches in terms of parameter space of things that we can model. Frankly, it's a little bit of a Wild West because we don't have any, or I shouldn't say we don't have any, we don't have very much data to constrain yet exactly how we construct our experiments. So really, to have a good shot at producing some work that is meaningful, you want to be careful in terms of how you define your research questions going in. What is it that you really want to learn about the type of target, or about a specific target, or perhaps how some process is represented that is important for understanding superficial habitability, as an example. Having that laid out clearly in advance really helps come to determine what your experimental design should be. And that's our next principle, is to come up with an experimental design that allows as many people in the community to participate as possible, and to spread the news widely. Why does this matter? Well, of course, this is one of these endeavors where the more the merrier, honestly. And so your experimental design should not preclude people from participating because the models that they use may not have a certain capability. For example, you can come up with a set of tiered experiments where you have some that everyone can do, and perhaps some supplemental simulations or experiments that a smaller group can do. We'll see an example of this in Costas's talk about CREM that follows next. But the point is to give as many people as possible a chance to get their foot in the door with a set of fundamental experiments that are at the heart of what the MIP is designed to address. And then tell everybody about it, right? You can post announcements to the AGU discussion boards. You can make announcements at any one of the numerous meetings that we are now all attending everywhere. Having splinter meetings, maybe even having propose a session that talks about the importance of tackling a particular kind of MIP. something that gets the word out, so that people know that it is going to be happening. And then plan a timeline that lets everyone actually engage. This is a hard one because so many folks are going to be participating more or less as volunteers. And so we have to respect that there are going to be other pressures on their time. So you want to have something that can move forward at a pace that allows as many people as possible to keep up, or at least to catch up at some point. Tomas' point about having monthly meetings is good because it allows you to gauge on a regular basis just how quickly the MIP as a whole is proceeding. And it gives people a chance to stay in touch and know, at what point they need to step in, perhaps, if their attention is drawn elsewhere for a time. Now, coming back to the foundations of funding for CUISINES from the Stellar's Exoplanet Environments Collaboration at NASA Goddard Space Flight Center, where a link to observations is really important. Please make plans to generate data products from your model output that can be used in comparisons to observations. We really need to be informing not only JWST, but eventually the Hab Worlds observatory folks, what their targets might be looking like, and perhaps even what kinds of instruments might be necessary to capture the information that we can find from our models. Even if you yourself are not somebody who is an expert in observations or doesn't normally deal with observations, please make sure that your model output is connectable to observation by someone else. And lastly, have a data management plan that works. So Thomas has gone through some tremendous efforts to set up CCAN, which Dennis showed you briefly, which is the main data repository especially for CUISINES, because as we looked around in the beginning, we found that there really wasn't any one particular site that was useful for exoplanet model output, as opposed to observation data or lab data. And so we have the CUISINES archive, I'd like to say at this point, where you can certainly keep your materials for any ExoMIP that is CUISINES endorsed. If for some reason there is additional data that perhaps isn't relevant to the MIP, but you want to eventually publish elsewhere, please keep in mind the same general principles of making that output both accessible and usable by your downstream users who may not be model specialists, who may simply be interested in the output and working with that. So these are all things to keep in mind as you plan your MIP. Now there are some special considerations. One thing that we have tried to emphasize is that as you proceed with your analysis, focus on the contrasts and the outcomes and not which model is quote unquote better. Because honestly, we don't know. We don't have enough data yet to tell us whether any one of our models is better, or in fact, whether or not any of our models is actually correct. They may all be wrong, but in some different way. So right now, what we're looking for is illumination in understanding the differences between our models. And that is intended in part to help individual modeling groups think about, well, is there some part of my model that that might be enhanced by doing things a different way? Or if my model gets something very different, why is it getting something very different? And is this something that we need to think about in terms of future code modification or adjustment? And also, we in this CUISINES community have a hierarchy of models from radiative transfer to 1D radiative convective equilibrium models. to EBMs, to GCMs, and beyond, right? So how do we leverage this unique opportunity that we have to engage with a variety of different models across the board? Again, in terms of the experimental design, having at least one or two experiments that are easily adaptable to perhaps other model types other than the ones that are originally engaged in the particular MIP. Or think about extending the parameter space for those models that are capable of stretching forward, and taking advantage of that to help inform some of the results or the benchmarks for the other model types. And I want to say that, from the outset, we have enough MIPs going on at this point that as you design a new MIP, you should really be thinking about, are there ways to interact with some of the existing MIPs? And there is almost certainly a way to think about connecting between the MIPs of various kinds. Again, Thomas mentioned some of the examples that are already in progress, and some others that we can think of that have potential for future interactions. But if you think about it right at the start, that can inform your experimental design also, and make it easier for those future comparisons. So just some general thoughts on strategies going forward. So one, don't wait too long before getting the community engaged, right? So I think it's great that Tim is going to be talking about his new soon to be unveiled MIP on interior processes, because this is really one case where too many cooks are not going to spoil the sauce, right? The more input you get, the more likely you are to be able to come up with an experimental design that really is inclusive of as broad participation in the community as possible. So as soon as you've got the idea and you've got the go-ahead from Thomas and Dennis as a CUISINES MIP, then get everyone involved through workshops, at side meetings, however you can make that happen. Another thought is that when publishing your protocol paper, I wouldn't worry about having a full set of results to show, because at that point, it's not really a protocol paper, in my view. It's already a result. Now, if you want to have some preliminary results to sort of whet people's appetites, that's great. But if you do it all and then publish the paper and call it a protocol, you aren't necessarily going to discourage people from participating in the future, but some folks may look at this and say, well, it's already been done, and decide that they will not join in, and that would be a pity. Now, I will say that you may run into some issues with paper reviewers. And so, in the process of getting the framework paper reviewed, because the framework paper does not have brand new scientific results in it, the infamous reviewer number 2 protested strongly about publishing the framework paper. I think it was partly because the editor had not tipped him off or him or her, I should say, had not tipped them off in advance that this was not meant to be a science result paper. But again, I don't think that you need to have a full set of results to get something published. And the Planetary Science Journal is used to us by now. And I think they will understand if what you're presenting in your paper is the concept for moving forward. I will also add that reviewer number 2 had complained and said, well, why isn't this just on a web page somewhere? You don't want it just on a web page somewhere. You want it formalized so that as the protocol evolves through time, as you have new iterations, we're already talking about TIE 2, for example, you will want to have documented what was originally intended to be done with the MIP. And the best way to do that is in a published paper, not on a website that has no permanence, honestly. So I will also add that if, as you are defining a protocol, you find that there are issues that means that you have to change your experimental design and strategy, this is an important part of why you were doing an ExoMIP in the first place. So please include it in your protocol paper as part of the history of getting the protocol accomplished. This is a science result, I would argue. And so again, if you are concerned about a reviewer not liking a paper because it doesn't have some brand new science in it, discovering that you need to take care of some things before you can go ahead with your intercomparison is science. And so include that. I think Malbec ran into this with their first paper. So please let everyone know. And by the way, also by letting everyone know, you are sharing the fact that this is a sometimes painful process, which is important for people to know going forward. And and lastly, if you have quote unquote extra data, so if there's something in particular about your own model's results that you want to write about independently of the MIPS work, then by all means put it out there. Whether it becomes part of a theme issue with the rest of the MIP results or not, remember to credit your ExoMIP. Getting the word out is really helpful. And with there, I will say thank you, and I will end with one other comment, putting my Nexus co-lead hat on again. So for those who are not familiar, Nexus is short for the Nexus for Exoplanet System Science. It is one of several research coordination networks that NASA established in the aftermath of the NASA Astrobiology Institute going away. And the purpose of these research coordination networks really is to get people engaged across the community. For Nexus, CUISINES is the shining star. It is the example that comes up every time when people talk about the importance of organic collaborations built among the community. It is incredibly successful, as evidenced by the fact that we keep adding new model intercomparisons, and there are no dearth of ideas for going forward. And so this kind of interaction is hugely valued at the upper echelons. We are trying to convince some of the RCNs to adapt a similar kind of framework for the particular work that they do. In fact, I had a conversation recently with someone from Enfold, which is all about life detection and mostly about instrumentation, about ways that they might adopt a CUISINES-like framework for getting all of their folks on the same page. So do not underestimate the value of what you are doing. This is super important, and it's really exciting work. And with there, I will stop. Any questions? Yeah, so I see Adith Pardis's comment in the chat. Yeah, and in fact, it was funny because the Enfold folks were talking about trying to come up with a protocol paper. But apparently in their community, there's some concern about sharing what might be potentially sensitive bits of information about the instrument packages that they create. So perhaps there is a bit of extra enticement that needs to go with that sort of work. But I think for us in the modeling community, that is not a concern. The codes are out there, they are public. And so really, let's share as much as we can, as broadly as we can.
Thanks, Linda. Thomas, do you have a question?
Yeah. Thanks, Linda. It was a great presentation. Thank you. Yeah, I wanted to ask you something. So when I presented Cuisine at John Hopkins like a few weeks ago, there are a couple of people from CEMIP there and Ocean CEMIP, and they reacted to one of the outcome we mentioned for Cuisine, which is eventually have a better agreement between the model prediction, and so improving the robustness of the results. And they were saying that it's quite dangerous for them because they say that it can lead the models into a wrong direction. But I wonder if the answer for that really depends on the amount of data we have in the environment, since we are data starved and we are doing a lot of prediction rather than a lot of interpretation. Is it changing? Why should we or should we not aim for a better agreement between the model predictions?
So on the Earth side, in the US, periodically there comes up this pressure to have just one US model, right? So right now there are 3 major modeling groups that contribute to CMIP. So one here is based here at GISS, one is based at Princeton in the Geophysical Fluid Dynamics Laboratory, and the other is based at NCAR in Colorado. And there has been huge resistance to cutting us down to one model, because the idea there is that with multiple models, you are getting different perspectives because the coding is all different, right? Nevertheless, you know, on the CMIP side, there often is data, voluminous data, to which the model results can be compared, and then the models are tuned in their own ways. So, so they are still arriving at broadly similar results in different directions. I don't think right now it is harmful for us to think about whether or not the results across our models are consistent. I think it's important to discover when they are not, and to think about why that may be the case. Ultimately, whatever changes are made to a code is up to an individual modeling group. And so no one should feel pressure to change their model to get the same answer that everyone else does, but to start by understanding why there is a difference in the first place. And once there is data that we can actually compare the models, model output against, then we can start thinking about, well, okay, so is there something that our models have that is fundamentally not capturing what we find in the data? Now we need to fix something. And still, people will go about fixing that in their own ways, right? Because every code has its own history. We're not all about to create one module that people can swap out from model to model, right? That's not going to happen. So I get where the ocean modeling folks have a concern, but I think they also don't quite understand where we are in our journey toward trying to understand why our models do what they do.
Yeah, thank you. Thank you.
Thanks, Linda. Any other questions? If not, let's move on to the next talk, which will be by Kostas. Kostas, whenever you're ready, just share your screen.